In this video, I'll complete the two remaining portions. That is low-code AutoML tools, where I'll explain the IEEE fraud detection, and the other one is a Kaggle competition for California house price. So these two are the two different data sets I'll be using in this, and I'll demonstrate how the AutoML tool works for this. So to begin with, for the IEEE fraud detection, in this I'll walk you through how AutoClone is used to predict the fraud detection IEEE data set. And I started by merging two data sets into one, that is training identity and the training transitions using a transition ID. So for basically we need to import the pip install and other things, like I'll mount the drive data, that is IEEE fraud detection, to the label evaluating metrics in the save path and other things. So once that is done, then with the merged data, like I use autoglue and tabular predict. So to train the model, focusing upon the high quality predictions data using ROC and AOC curve. So those two are for evaluating the matrix. So here the quality will be good, and ROC and other curves will be here. So for evaluating the matrix, like I use excluded a neural network on this static model to keep this efficient. For the test data set, I ensured a consistency by replacing column hypothesis with underscoring and filling missing value with 999 thing. That will solve the missing values and other things. I merged the test data set similarly to the training process, and then I use the training model to predict the probability of the fraud detection. Finally, I created a submission file that is mapping to the probabilities and sample submission format. This process will give us a powerful, efficient model for fraud detection with a minimal manual tuning and other things. So this is all about the IEEE fraud detection, like how I tackle these problems and using a different. Where here I explicitly went for Collab Pro, and have run with RAM, that is 300 RAM. So I connected with this. And the next one is the California house prediction. For this, I'll explain how I built house prediction model using AutoGlow and multimodal prediction for the California house prices data set. The first I designed a Python script that leverage different models as a stacking, weight, ensemble, and the single model approaches for the prediction. And I also included a fusion model for the option for to use the transformers or MLP architecture. I prepared the dataset to adjust the features of LOT and the taxes asset value using logarithmical scale to clean up the categorical columns. So here is a data loadation and other things. So here is the model for data pressure and AutoML hyperparameters and data process. And here is this let's sit on the training model for this, and later will be predicting multimodal predictor. And once that's done, then we export the data and install the Torch Vision and install the Torch Vision, because I saw the error while running this. And here is the drive the connection to the model. And once this is done, then here are the examples for others as well. And at the removing the existing directory is the base command. Now the directory will be empty out of scripts. In this, by overall I process the data by adjusting features like LOT and the tax assured values using a logarithmic scaled model and categorical columns. Then I used AutoGlow and tabular predict and multimodular predict for the training modules and evaluating the best based R square performance after predicting were made. I post process them by applying the exponential function and created a submission files. This process will showcase how to use a utilize autogluons for a complex task like power spreads predictions, like a coefficient and other things. So this is an example about the using these two different data sets from the Kaggle computation. Thank you.